Hey folks, we're going to talk about same line. Are these points on the same line? So if we are looking at these points, we are curious, are they on the same line? So what we could do is we could graph this. We absolutely could graph this and see if the line is straight and has a constant rate of change or a similar slope. What we can do if we don't have a graph is we can get the rate of change or the slope between these 2 points and compare it to these 2 points. And that's what we're going to do. So we're going to use our slope formula and go x1, y1, x2, y2. And then we're going to put that into our formula. So I have 3 minus -1 over -2 minus -4. All right, so 3 minus -1, this is where it's great to know our integers or have some sort of help. A calculator tells me that this is 4. -2 minus -4 is -2 plus 4. -2 plus 4 is 2. So this gives me a slope of positive 2. Now, so I'll say m equals 2. What I want to do is I want to compare that to the slope between this point and this point. So now this is x1 and this is y1 and this is x2 and this is y2. And I'm going to set that problem up now. So when I do that, I'm going to do 1 minus 3 and -3 minus -2. All right, so 1 minus 3 is -2. All right, and immediately it's like, wait, this slope doesn't match. But again, we're not done yet. -3 minus -2 is -3 plus 2. So that's -1. Now I have -2 over -1. That makes this slope positive 2. So m here equals 2. So that is the same slope. Are these points on the same line? Yes. All right. Now, because I know they're on the same line, I can look at between this point and this point, and I'll do that now. I'll show you what I mean. If I say this is x1, y1, and this is x2, y2. I should be able to use any of these points, really in any way, but any of these points, and I can compare their slopes. So I can say 1 minus -1. Now, you don't have to do this every time. I'm just proving that you could use this set of points. 1 minus -1 over -3, that's x2, minus -4. And if I do that, 1 minus -1 is positive 2. -3 minus -4 is -3 plus 4. That's positive 1. That gives me a slope of positive 2. So between these two, m equals 2. So any way I look at this, the slope between these 2 points, and these 2 points are the same. So these points are on the same line. So what are we going to do now? We're going to jump down here to this one, and we're going to set this up. I want to know the slope between this so I can compare it to the other item. So x1, y1, x2, y2. So 3 minus -2 over 4 minus -4. All right, 3 minus -2 turns into positive 5. 4 minus -4 turns into 8. So the slope between here, m is 5/8. All right. Now, I'm going to pick these 2 points, and this is now going to be x1, y1, x2, y2. All right, so -4 minus 3 over 3 minus 4. All right, -4 minus 3 puts me at -7. 3 minus 4 is -1. So this is m equals, that's positive 7. M equals 7. Well, these slopes aren't the same. So these are not on the same line. This line would go from here to here. It would go up, and then it goes down like this. That's not one continuous line. So these points are not on the same line. And it's because I got two different slopes when I compared those points. And if I did from this to this, it wouldn't give me either one. It doesn't matter, because between this and this and this, these should all give me the same slope. So these are not on the same line. All right, now you will be doing this one, you will be doing this one. I want to go, I know points are on the same line because they have a constant rate of change. And what that means is they all have the same slope. All right, when I'm talking about constant rate of change, I'm talking about the slope of that part. Well, the slope between here is different than the slope between here, so these are not on the same line. But if I look at the top, the slope between the two purple points, the slope between the two green points, and the slope between the two pink points, it's all the same. So they all have the same slope. If they're on the same line, they all will have the same slope. All right, you got something to try.